Hello students and welcome to my channel Maths Hub. So in the previous video I talked about symmetry, about various theta equal to 0, theta equal to pi by 2, theta equal to pi by 4 and theta equal to 3 pi by 4 lines. And we also talked about whether the curve passes through the pole and the tangents about the poles. Now in this video I'll focus on the asymptotes, how to calculate asymptotes in polar curve, right? So first of all, as if you haven't watched my previous video on asymptote in Cartesian coordinates, do watch it. It will give you an idea what is an asymptote. Now, how do we calculate asymptotes for polar curve? Simply, you need to put the equation that is given to us in the form of 1 by r is equal to f theta, right? So we will take the reciprocal of r and we will put it equal to f theta. And then we have to put f theta equal to 0 and we have to find the root of this function, right? So whatever root we get, then the equation of the asymptote would be r into sine theta minus alpha is equal to 1 upon f dash alpha, right? So the first step is take the reciprocal of r, put it equal to f theta, then put f theta equal to 0, find the root of that equation, mark it as alpha, and then the equation of asymptote will be r into sine theta minus alpha is equal to 1 by f dash alpha, right? So let us take a exercise and let us solve how to calculate the asymptote of this curve. So the first step is let us calculate what is r, right? So r from this equation is basically a cos 2 theta divided by sine theta, right? So the first step is to calculate the reciprocal. So we will take 1 by r and we will get sine theta divided by a cos 2 theta, right? Now the next step is, now this whatever we are getting on the right hand side of 1 by r, we will mark it as f of theta. And now let us put f of theta equal to 0. So we put sine theta upon a cos 2 theta equal to 0, right? And now when I put it equal to 0, obviously we will cross multiply and we'll get sine theta as 0. So that implies theta is equal to n pi, right? Now once we get theta equal to n pi, we got the root. So now let us calculate what is f dash theta, because we need to calculate f dash at n pi. So we have to apply the quotient rule. So we take the denominator square, cos square 2 theta. We start with the denominator cos 2 theta into derivative of sine theta is cos theta minus, then we will write sine theta, then derivative of, okay, there is also a, so we will write here a square. I'll write here a cos 2 theta and then sine theta in the numerator, and then derivative of a cos 2 theta would be minus a sine 2 theta into 2, right? Okay, so now let us substitute theta as n pi. So we will get a cos 2n pi into cos n pi. Minus into minus will become plus. So we will get 2a sine n pi into sine 2n pi, right? Divided by denominator is a square cos square 2n pi, right? Now we know that sine n pi is always 0. Similarly, sine 2n pi is also 0, right? And now what is cos n pi? Cos n pi is minus 1 raised to power n. Cos 2n pi will be minus 1 raised to power 2n. Denominator is a square, then minus 1 raised to power 2n, and then it's square, right? So now this would be an even term. So this is plus 1. This is also plus 1. 1a will get cancelled. And what we get is minus 1 raised to power n upon a. This is our f dash n pi. So how to calculate the equation of the asymptote? It is r into sine theta minus alpha is equal to 1 upon f dash alpha. This is the equation of the asymptote, right? So now let us substitute the values. So we have r into sine. Theta minus alpha is n pi. And 1 by f dash n pi would be a upon minus 1 raised to power n. Right? So let's open up the brackets. Let's apply sine a minus b. So we will get sine a cos b minus cos a sine b. Right? So this is equal to a upon minus 1 raised to power n. So again sine n pi will become 0. So we will be left with cos n pi. So we will have r into sine theta into minus 1 raised to power n is equal to a upon minus 1 raised to power n. So you can see that both will get multiplied and it will become 2 minus 1 to the power 2n. So that will convert into a positive number. So we will have r sine theta is equal to a. So this is your equation of asymptote, right? So I'm again repeating the entire process quickly. So from the equation of the curve, we will calculate 1 by r. Whatever we get on the right hand side as a function of theta, we'll substitute it equal to 0. And then we will solve it to get the values of theta, right? Once we get the values of theta, we will calculate the derivative of f dash theta. We'll substitute that root and we'll get the value. And then the equation of the asymptote is r into sine theta minus alpha is 1 by f dash alpha. Just solve that equation and whatever we get at the end, that results into the equation of the asymptote, right? Okay. So now another important thing that we need to take care while tracing a curve is some regions. Now to get the regions, like we prepared table for x and y in Cartesian system, we can similarly prepare the values of r and theta. We can put some values of theta and we can get the corresponding values of the radius vector, right? And then how to check the regions of absence. Now for if any particular theta, if it lies between alpha and beta, if the value of r square is less than 0, right, the radius cannot be negative. The square of the radius cannot be negative. So that means no curve will lie between the regions theta equal to alpha and theta equal to beta, right? And mostly when we are tracing curves in polar system, we are given curves in the form of sine theta and cos theta, right? So whenever mod of sine theta is less than equal to 1 and mod of cos theta is also less than equal to 1, then for those curves r equal to a cos n theta and r equal to a sin n theta, mod r is always less than equal to a, right? Because whenever we have r equal to a cos n theta, if I take mod on both sides, cos n theta is obviously less than 1, so r will be less than equal to a. So that means no curve will lie outside the circle of radius r, right? So this is another important point that we need to take care, right? So I hope you have understood asymptotes, right? And how to check the regions of absence, right? So thank you so much for listening to me, and do subscribe my channel to get the latest updated videos, and believe in yourself, you'll definitely do it. Have a nice day. Thank you so much.